At this time, you're probably feeling like you're going to law school because we get to talk about yet another law. So when we're talking about the relationship of temperature and volume, this is Charles' law. If we increase the temperature of a gas sample, the kinetic molecular theory states the motion or kinetic energy of the gas particles will also increase. So if the amount of pressure of gas is held constant, the volume of the container will increase. So our learning goal for this one is to use the temperature-volume relationship, otherwise known as Charles' law, to determine the final temperature or volume when the pressure and the amount of gas are constant. So here's an example. In Charles' law, the Kelvin temperature of gas is directly related to the volume. So V1 over T1 equals V2 over T2. Okay? And the pressure and the moles of gas are going to be the constant variables. No, well, that can't be a constant variable. They're going to be constant for this equation. And when the temperature of a sample of a gas increases, the volume is going to increase at that constant pressure. So you can see a little diagram over here where we have temperature and volume is here. And then when we increase the temperature, the volume is also going to increase. So for two conditions, the Charles law is written again, V1 over T1 equals V2 over T2, and P and N are going to be constant. So rearranging it, we can solve for V2, and we would obtain the following. That V2 equals V1 times T2 over T1. So let's apply. So let's try our hand at this and solve the Charles law expression for T2. Okay. Pause, think about it, come back. So simply cross multiply to give the following, and then we're going to isolate the T2 by dividing V1, and so then that ends up rearranging for T2 equals T1 times V1 over V2 over V1. All right, so let's try to apply this. So if a balloon has a volume of 785 milliliters at 21 degrees Celsius, if the temperature drops to 0 degrees Celsius, what is the new volume of the balloon at a constant pressure in moles? So step one, let's organize. We're going to organize the data into the table of initial and final conditions. So we have condition 1, condition 2. What do we know? The temperature is going to decrease. What are we going to predict? That the volume is going to decrease as well. And again, the pressure in moles are going to remain constant. So let's rearrange the equation so that we can solve for the unknown quantity of V2. And then we're going to substitute the values in for the letters, and we're going to be able to calculate that V2 equals 729 milliliters. Okay, so let's try it again. So a sample of gas has a volume of 420 milliliters at a temperature of 18 degrees Celsius. At one temperature in degrees Celsius, will the number in oxygen be 640 milliliters? Again, P and N are going to be constant. So pause me and come back. So let's set it up. Our conditions 1 are here. Our conditions 2 are here. We know that the volume is going to increase, and we can predict, using this law, that T is going to increase as well. So let's solve for T2. Okay. And then plug in the numbers, and you can see that the answer is going to be 170 degrees Celsius, or B. Right? So let's apply that again. So use the gas laws to determine, or to complete each sentences with increases or decreases. Okay, pause me and come back. So did you guys get for A that pressure increases when volume decreases at a constant temperature in moles? And that when temperature decreases, volume decreases at a constant pressure in moles. For C, the pressure is going to decrease when the volume changes from 12 liters to 24 liters at constant temperature in moles. And the volume increases when the temperature changes from 15 degrees Celsius to 45 degrees Celsius at constant pressure in moles. Great job, guys.